Hi, my name is Jose Luis, and welcome to this new video where I'm going to explain to you how to create a library of code. The idea is that this video belongs to a series where I've been teaching you how to learn computer programming using C#. And in the previous video, we learned how to create classes, and we worked a lot in this one class that was designed to represent vectors. So we have XYZ properties, we have constructors, we have a lot of really good, we spent quite some time making a very nice vector class that then we were able to use in this console application that has the main function which executes, it creates these two vectors, it operates with them, it prints them to the console, etc., etc. The idea is that when we did this, we created a console application where we wrote the code that we were designing, so this really empowered vector class, but at the same time, we wrote this main program that was going to be using that class that we created, right? And if you think about this, the idea is that as computational designers, you may want to start creating your own code, your own classes representing geometry, for example, or representing other kinds of things. And the more you start building and working on those classes, the more you may want to reuse them between the different programs that you may just write at some point. But if this was the only way to do that, just basically writing here the vector class, then it would be very tedious because whenever I would want to create a new program, I would basically have to like copy paste the code with text into my new program, and that sounds tedious, prone to error. Like it sounds like something that doesn't really work. So what's interesting is that in the world of .NET, there's this thing called dynamic link libraries, or DLLs, which is a form of taking a lot of code that has been designed to be reusable, packing it into a file, and then being able to use that file and exchange it and reference it between different programs and access the functionality that is contained in that class, in that file. That makes that container, the DLL, it makes it a container of all your goodness and all this like super empowered port that you create, which can be reused in a lot of different environments. And literally, this idea of packing code into one file that can then be reused by a lot of programs on a lot of parts of your environment is the foundation of how, for example, the Windows OS works. Windows is basically tons and tons of DLLs that are used and shared by many of your processes, and those get updated, those get improved, etc., etc. So what we're going to do today is I'm going to show you how to take this vector class and make its own project, turn it into a library that we can pack and ship into a file, and then use it in any other programs, like for example, a console application. What we're going to do is, instead of only working with the vector class, I'm actually going to expand this idea a bit further, and I'm going to write a small geometry kernel. A geometry kernel is typically referred to as a bunch of code that represents a lot of geometrical entities and that depend on each other. And I'm going to do that using code that I have previously written. So you will be able to download that code from the sample files. And that code is going to have a vector class, a point class, and a line class. And we're going to be able to operate with them, okay? I'm not going to build those classes in this example. What I'm going to teach you is how to pack those classes that you may have worked on, how to pack them into a library, and then how to build that library, and then how to reference it from other environments, okay? So let's get busy. Let me show you how to do that. Alrighty, so the first thing we're going to do is we're going to create a new project in Visual Studio. Now, all through this playlist, we have been creating console applications as the simple kinds of programs that we can basically write in any environment. For this one, we're not going to do that because we don't want a program, really. What we want now is we want to create some abstract container for code that we can populate with our code, but then we can use somewhere else in a different program. What that means is that we're going to create a new project, and then we're going to be using .NET framework, okay? But instead of a console application, what we're going to do is we're going to search for a class library. All right, and I'm going to go here to class library .NET framework. This is the one that I'm going to want to use. Oh, what have I done? Oh, is this a class? No. Okay. All right, so new project, and then I'm going to go here, class library, and then I'm going to double click here and going to say class library for the .NET framework. I'm going to put this somewhere in my desktop, for example. What is my desktop here? Yes, and I'm going to call this class library, I'm going to call it my geometry kernel, okay? Because I'm going to create a small bundle with a lot of geometry object classes, and I'm going to call it my geometry kernel. So my geometry kernel. All right, I'm going to put it in my desktop, and then at some point we may want to talk about what .NET framework version we may want to choose in our lives. The earlier you go, the more compatibility you are ensure with the rest of the .NET world, but the less of the nice functions you have. So I'm going to choose 4.5 is about right. Okay, I'm going to create this project, and then Microsoft Visual Studio will be creating this new thing that if you look carefully, you can see that now, as opposed to when we had a console application, that we had a class program with a main function, and this is where we wrote our main code, we don't have that anymore, because a library of code doesn't really have a main program. A library of code doesn't really execute any program. A library of code is just a container of functions and a container specifically of classes. The only thing that we can actually write inside of a library is classes, right? And it's those classes that will contain those functions, those variables, and all the goodness that you want to pack. But there's no main executable program anymore. If someone wants to use the code that is contained in a library, then you have to reference that library into some other program and then be able to use it, which we will do by the end of this tutorial. Okay, so what I want to do is I want to use this project, this library, to pack in a lot of the cool geometry functionality that I may write at some point. I have some sample code that I'm going to copy paste here. I'm not going to explain that, but if you're interested in that, you can check my previous videos. So the first thing that I would like to do is, for example, I'm going to create a class representing vectors. We've done that in the previous video. So what I'm going to do is I'm just going to copy paste this whole class, and I'm going to take this and I'm going to paste here this large vector class that I created. You see, it's a class vector. It has x, y, z properties. It has the vector, etc., etc. It has all this really cool stuff. And then what I'm going to do is I'm going to rename this file here. I'm going to rename it vector, just because it's typically good practice, your class files, to rename them with the name of the main class that is contained in that file. All right. Now, I said that my sample code, the one that I'm copy pasting from somewhere else, also has lines and vectors. So what you probably want to do is you probably want to have each one of those classes in different files. So I'm going to go here and I'm going to say, I'm going to right click and I'm going to add a new item to this project that I'm running on, my geometry kernel. And in the items, you can see that there's a lot of stuff that you can actually add. There's like tons of things that relate to the C# world, the .NET framework, etc., etc. But you see how Visual Studio is already recommending that the one we want to add is probably a class, because this is a library of code. So I'm going to do that, and I'm going to name this one point. Okay, and you can see that a new file shows up here, and it has an empty class of the type point. So I'm going to copy and paste some code that I did somewhere offline, and that is also representing a point. For example, it's a point class. It has XYZ coordinates. It has a couple of constructors that allow me to create it, and it has a very simple function to calculate the distance to another point. All right, and then we're overriding the toString method to make sure that this gets serialized in a nice way. And on top of that, so I'm going to save this, I'm going to save this as well, and then on top of that, I'm going to add another class, which is going to be lines. All right, So I'm going to right click here, add new item. I'm going to go click on class, and this is going to be a line class. Then this file pops up here, and then I have an empty line class, which I'm going to copy paste from somewhere else. Okay, I'm going to copy paste it from here, and I see that I have an error here. This should be vector, not my vector. Okay, and this line has, as you can see, the start XYZ, the end XYZ. These are doubles. They could be points. They could be a starting point and the end point. You can get the length of the line, and it also serializes to a string. Okay, nothing very complicated. Nice. All right. So now that we have a library that contains three main classes, and this could be whatever, you could start adding here meshes like topology optimization, like blah blah blah, all this really cool stuff. But so you can build over time your own super empowered library of things. You could even write a library with all the code and all the geometry gems that we have been learning in this channel in parametric camp. But one step at a time. So what I'm going to do now is I'm going to start this program. Okay, and what happens is that if you notice, I get this error message that says that a project with an output type of a class library just cannot be started. Okay, because for the reasons that I just explained before, this is not a program. This doesn't really have code that someone is typing and is asking to be executed. This only has classes, vectors, points, and lines, which can be used by some program that we still haven't written. So a class library project cannot be executed. It's like a book. It's sitting there waiting for somebody else. When you write a book, it doesn't really execute. It's like sitting there waiting for someone to use it. If somebody picks up the book and starts reading it, that is the program. That is who executes the program. All right. But so class libraries cannot be executed. But what they can be done is they can be compiled and they can be built. What that means is that when you compile and when you build a library, what you're basically doing is you're taking, let me show you. Let me show you, where do I have this file? Yes, so if I open my project on my desktop, you can see that I have a Visual Studio project that has the main solution file, it has the project, it has the three files, and I can open this on any text editor that I want, okay? So this is my whole project. This is my source code, okay? This is what I own as a developer. But if I want to take all, and this right now we have three classes, but if we have 3,000, basically it would not be nice to just share the 3,000 files with someone else. There's a way to take them all and to pack them into one single file that can be reused. And the way to do that is by doing what we just did. Well, the way to do this is by going ahead and saying, well, instead of executing the program, what I want to do is I want to build this library. So you can go here and then you can say, let me build this solution. All right. And I don't get any error message anymore. And you can see here that I have 1 up to date and 0 succeeded. This should be 1 succeeded, but just because when you start so when you start a class library, it actually builds automatically that file. So that's why it's already up to date. And then where does that file live? Well, what this means is that we have built this DLL file. DLL is the extension that all dynamic link libraries, so class libraries in .NET, that's the extension that they all have. And where is this? Well, because we were in debug mode, we were in like development mode. If we go to our project, our main Visual Studio project, we go to binaries and we go to debug, you can see that I have my geometry kernel.dll. This is the file that contains all the code, my vector, my point, and everything. It contains everything packed. It contains everything in a single file that then I can reuse in other environments. Okay? And what is in release? What is going on in release? And there is nothing in release, but what I could do is I could change the mode from debug to release, and then build again. I'm going to build a solution. You see, I'm building blah, 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 whatever, succeeded. So my file should be there. If I go to release, now I have this DLL file here. The PDB file is actually not very important. It's more of like a database, it's we don't really need that for anything. So you can delete that, no problem. Okay. And what is the difference between debug and release? Well, when a library is built in debug mode, it's built in a way that it's easier to measure its performance. It's easier to pick up some errors, but it's a bit heavier. So that's good for when you're writing code, but when you're going to actually just pack this in the most optimal way for somebody else to use, it's better to build it as a release version. Okay. So this file here is now the file that contains all the goodness with my vectors, my points, and my lines. So how about we now try to load this library into some other project and then use that goodness in some other C# project, okay? Let's see how that works. What I'm going to do now is I'm going to open a new instance of Visual Studio. So I'm going to open a new Visual Studio project. And what I'm going to do now is I'm going to create a new program. We have seen so far that the easiest way to create programs is to create console applications. So I'm going to use one of those. I'm going to create a new project that's going to be a console application in the .NET framework. I have it already on my recent project templates. And I'm going to put this again on my desktop. I'm going to put it on my desktop. And then I'm going to call this console app using my geometry kernel. All right. And then also 4.5. Because my library was 4.5, I'm just going to use the same library, the same version for both. Okay. Now, as we do this, we're going to be in a very familiar position, which is now we have our main program, our main class, and here I can write console read key to pause the program, and here I can say console, I don't know, write line. I'm sorry. my keyboard is doing crazy things these days. I need to buy a new keyboard. Hello world. All right. And all right. So and then if I execute this, we get a window here. We already know. Oh, all right. All right. So what? Okay. All right. And then we get our window here. Okay. So that's fine. We're already very familiar with this process. Now, what I would like to do is I would like to do something where I can say now vector v0 equals a new vector blah blah blah, etc. with the code that I have created. But you can see that because I just started this console from scratch, vector and vector, even though I created them in the other project, they don't show up here. Okay. And that's perfectly normal because this console application doesn't need to know where all the code in my whole computer is. So what I need to do is I need to make sure that this console application is pointing directly to the DLL that I referenced, and then make sure that it's properly loaded. The way that works is that you have a tab here called references, and references is, if I expand this, you can see that there are a bunch of things that are being referenced in this project, and that's why this project is working, because I have the system core, data, all these like really fundamental libraries in the .NET framework. So what I would like to do is I'm just going to right click here, add a reference, and then I'm going to find in my computer where this DLL with my geometry kernel is. So I'm going to browse here. I'm going to go to my desktop. I think I have my geometry kernel binary release. And you see that my file is showing up here. So I'm going to reference the DLL. I'm going to add it here. You see that it shows up here, and then I'm going to click OK. And you can see that my geometry kernel as a reference is now part of my project. So my project knows now, my console application knows where this lives and can read that code. All right. Yet, it is still not working. The vectors are still giving me an error. Why is that? Well, my console application knows where my geometry kernel is, but in this particular file that I'm working on here right now, I am not using that reference, okay? And we haven't really spoken about this yet, but you can see here how at the beginning of any C# file, we have this series of using statements that what they're basically saying is that this file, the code that I'm going to write in this particular file, is going to be using code that is contained in external references. And we have given all of this for granted, right? But for example, the console object is actually not, it doesn't belong to C#. It actually belongs to the system library, right? And if we were using like a list of vectors, whatever, that belongs to lists, belong to the collections generic. So these are like super fundamental ones. So what I need to do is, in order to make sure that vector and that everything that is inside my geometry kernel is accessible from this file, what I need to do is I need to make sure that I load that library into this file by writing using and then typing my, and you can see how it already autocompletes my geometry kernel. All right, so I'm going to type tab, and then I'm going to press semicolon, and you can see that how now this has gotten fixed. So now I have my vector class, and then I can say right line the value of vector 0, you see, and then this shows up here. And then, but I also have, for example, I have my point P equals a new point at coordinates 3, 4, and 5, for example, right? And then I'm going to console right line the value of P. So I'm going to run this 3.5, and then a new line, for example, line L, a new line from, for example, start point and end point, or what are the other overloads? Start and direction. So I guess I need to create 2 points, or a point in a direction. I can use P and I can use, I can use P and I can use V0. All right. And then as I run this, let me print to the console right line. That was confusing to say. You see a line from here to this other point, which is the one that is defined by this vector. Okay, so nice. So now we have the power to use, and we could now just write a full-fledged program that uses vectors, points, and lines, etc., because it has been properly referenced here in my geometry kernel. Okay. One thing you may have noticed is that actually, and this is not very nice, is that the fact that when I was writing my geometry kernel, I was actually super generous with comments, and this is a super good practice to do, because since I was writing comments in a C# like way, these comments are very useful when I'm writing programs to get like highlights and to get helper text, etc. And since I'm writing this code as part of a library that I hope to reuse myself, that I hope for other people to reuse themselves, writing comments so that those comments show up when I'm writing code. So for example, vector v equals new, you see, new vector. That is actually really good practice. The problem is that I am not getting any of those helper texts here at all, which it's kind of a shame because they are in those comments, those formatted comments are on the original file. So this is kind of a shame, and the only problem is that this is because when you create a new class library in Visual Studio, by default, the option to export these comments is disabled, right? Which is really, I think it's actually a really bad thing. So let's do that. So what I'm going to do is I'm going to right click on properties. I'm going to double click on properties, and I'm going to go to build. Okay. And in build, when you have this option here that is called the XML documentation file, and what that means is that we need to activate that so that whenever we build, we also export an XML file that has all those comments embedded. So I'm going to save this, and I'm going to now build my code again. So I'm going to build the solution again, and you can see that if I go to my geometry kernel bin release, I now have the DLL file, but I also have the XML file, okay? And if I open any text editor, for example, Visual Studio Code, and I drop my XML file here, you can see that this is just like a human readable text. It's nothing special about it, right? But what's interesting now is that because we have an XML file that goes with that DLL side by side, then now on any program that loads that DLL, if I now type vector, you can see the vector v equals a new vector, and then as I open parentheses, all of a sudden this text, this helper text, is new. And this is, I create a vector with 0, 0, 0 coordinates as a copy of another one, a vector from XYZ coordinates. These are actually the comments that I added here when I was writing the constructors. All right. So, and similarly for lines, for example, so I could write line else equal new line, and then here I get create a line object from 2 points, or create a line objects from a point and a vector. All right. So this, the idea of packing in helper text that comes from formatted comments is a really, really good practice. I love it. I like it a lot when other people do it, and I try to do it in my programs all the time. So make sure to remember to turn on the properties, to turn on exporting an XML file, and to comment your code generously for other people to read it, and for yourself, for future self. Okay, you will always forget why you did certain things and how certain things work. The last thing that I wanted to say before we wrap up this tutorial is to be mindful about the relation between the project that is running all your classes, so the class library, of where that is, and the project that is using those libraries. Because the way we've done it so far in this example has been that we have referenced from our console application, we have referenced a file that lives on the other project on my geometry kernel as a DLL. All right. What that means is that because the console application is looking directly at the other project, if somebody messed up with the other project, if you change it from location on your system, or you change the name or whatever, or for example, you accidentally deleted this DLL, this project would not work anymore. If I tried to run this, it actually runs somehow. I'm not sure why it runs, but it will probably break if you actually if you don't if the files are not properly linked. Okay, so if you change the name or whatever. So one option to go about that is, if what you have is a file that somebody has given you, but like a library that somebody has given you, you download it from the internet, etc., but you're not going to be changing it, or you're not going to be working with it, a safe practice very often is to take all that file, copy it into your project, and then say, for example, I'm going to go to my console application, I'm going to write here, I'm going to add a folder called libraries, and I'm going to paste this. And then in my console application, when I browse for this, instead of browsing in the original project, instead of that, what I may want to do is I may just want to reference this local file that I just copied and that I embedded into my actual console application. And because that's going to go nowhere, anytime I move my whole console application or rename it or whatever, that file will still be there and I will never lose that link. Okay? So that's one way to go. But another way to go is, if you're actually very actively working on your geometry kernel project, so you're adding vectors, points, whatever, blah, blah, blah. And for example, you have a console application that you're using just for the sake of testing it out, because while you're writing code, you may want to test if it works or not, right? And you can't do that from the console, from the DLL project. You have to do it from a console application project. So if you want to do that, then you can either point to this directly, or even better, you can actually load the whole library project. You can load it as part of your solution and then work with the console application and with the library at the same time. The way to do that is that if you, instead of the way to do that is that Visual Studio projects have two levels. They have the project, which is, for example, a console application, or which is a library, and the parent level is the solution. The solution is like a container of projects, if you will. So, because my console application is a project, but my geometry kernel is also a project, then I could create a solution that has both things. So, for example, my solution here is going to have the console application, but I'm going to add another project, one that already exists. So I'm going to add it. I'm going to go to my desktop, and I'm going to add my geometry kernel here. I'm going to add the project file here. And what happens is that you can see that my geometry kernel now actually shows up here. I can double click here and I can modify the vector, for example. I can change something in the vector, code, whatever, etc., etc. And now they're both linked together. And now what you need to do is you need to change here in the references. You need to remove this reference so that we make sure that we're not pointing to the one file, the one DLL anymore. But what we're doing is, and you see everything is broken now, but what we want to do is we want to say this reference, we should add a reference now, but instead of a file that lives in my system, I want to link to the whole project that I just loaded in my solution. So this, my geometry kernel as a project, is not anymore the DLL, is the full project that I have embedded here. And if I do that, you can see that now I have everything works well again. But if I now make changes to my code, so for example, vector creates a 0, 0 vector, and now I'm going to change this from my vector to vector. That was a typo, right? So now as I go here and I say vector v equals new vector, you can see that now the text has changed and that both things are linking dynamically together. So this is actually a very good way to go if what you're doing is you're developing this part and you just want to have a console application that you use it to run, to test, etc., etc. Because you can make changes to both things in the same place without having to like change something here, build the thing, go to the other project, etc., etc. All right. So yeah, so I think that's everything I wanted to say. This was building a dynamic link library, aka a library of code in C# in the .NET framework. Okay. If this was useful to you, please like this video, subscribe, etc., etc. This video is part of a larger Learning C#, an introductory playlist for people who want to learn how to code. You may want to check that out as well. But otherwise, thanks for seeing this, and see you on some other video.